Welcome to another month where proof is possible. I will be taking questions at the end, so please do feel free to keep the questions coming in the questions pane, and I will be answering all of those at the end once I've gotten through this month. So, as always, first Wednesday of every month, I show you a job that we used advanced building testing, not the baby stuff that we all know, but really hardcore stuff, so you can see what is possible in actually testing and solving people's problems, because remember that they want proof that the work was done right. And if you were the only person in your entire state, which in many cases you will be, that is offering that proof, those guarantees of measured home improvement or measured home building, then you win. And you can charge rates that are appropriate for that. So in case you don't know me already, I'm Corbett Lunsford. I'm a building forensics guy. 7 years ago, I was not in building. I was a ballerina piano player. So I used to hang out with girls in leotards all day long playing music that I made up. Didn't know anything about trusses, so please feel free to ask dumb questions, because even though this is all about being a ninja, I came from knowing nothing about houses, just like many people in this field do. So obviously half an hour on a webinar, even as fast as I talk, is not enough. So if you need more stuff, there is more videos, there is a free radio show, all that stuff is available on my website. And the one thing that I want to plug is if you want to become a master, there is something at the end of this webinar that I'm going to talk about, which is the fall fast track. But obviously there's the book and the software and all this stuff. Basically, I'm just trying to make it as easy as possible for you to plug this into your own business so you can make more money doing better work for happier clients, because it makes me crazy when people do crappy work and they charge crap prices for it. No one wants that. The homeowners don't want it. We don't want to be doing that kind of work. You want better. So here is the job from this last month. This was really, really fun. And in fact, I'm going to just say right now, this is the best Mastermind webinar that I've ever done. So you're in for a treat. First of all, this house is brand new. 6 months old, it's 4,800 square feet. As you can see, it's 3 stories over a finished basement. So pretty big. That's a standard Chicago lot, 25 feet wide, 125 feet long. For those of you in the rest of the country, that might seem pretty tiny. Their electric bill was really high in the winter. He actually went so far as to analyze his bill in March and his bill in April, and he found out that it went way down once spring came. So he thought that probably the heating was the problem. And he was also having a hard time keeping all the rooms at the same temperature. So all of this obviously motivates a homeowner or any client who has a building to get the problem solved. And they want somebody to solve it. So of course, the first person you call when you have a trouble conditioning problem is the HVAC expert. So he calls an HVAC, and I don't know how you call an HVAC expert, but the people who are actually measuring stuff, those are the experts. So he called an HVAC person, and this person was smart enough to say, you need testing, first of all. Secondly, I think that your equipment is too small, it's working too hard, and that is why your electric bill is high. Therefore, I'm going to give you a bid to that effect. So the day that I go out to test, because this is what this gentleman wants, is on an 82-degree day. Now, that's not super hot, but it's hot enough. And in fact, I do testing all the time on 70-degree days. When it's 70 outside, 70 inside, it's fine. So don't be nervous about this kind of shoulder season if that's what you're in right now. So my mission with this client, obviously, as always, is to pinpoint his opportunities for improvement and then give him a list of things that he can do to make his life better, not to save energy, necessarily, unless that's what he's specifically asking for, which in this case it is, or to make the world a greener place or to be sustainable or any of that stuff. I'm trying to solve his pain. That is all my job is. So I find out what his pain is in detail first before I go in and start testing stuff. Secondly, this house was just built. So part of my job is to find out what the builder did not do that is required by state law. And maybe he forgot about it, maybe he intentionally didn't do it, maybe he knew he was supposed to do it and just time got away from him. In any case, I'm working for the occupant to go after the builder. And this is something for me, someone who works with both builders and occupants, that I tell my builders all the time, listen, I would love to work with you. I will be testing this house, or someone like me will be doing this. And it can either be me with you right now, helping you to prove that you did it better than your competition and therefore can charge better prices for it, or I will come back and test this thing for the occupant and I will be your enemy at that point. And it's not up to me, it's who hires me. So the interesting thing here is that Chicago is where this house is located, and Chicago thinks that they're special. They think that they don't have to enforce a state law. The state law is 2012 International Energy Conservation Code. Chicago enforces the 2006 International Energy Conservation Code. So we have a problem in that the builder probably was not enforced to the state code, but that doesn't mean that we can't sue them and win with no problem whatsoever if that is what it comes to. And that is what it comes to because homeowners want what they want, and they want every house to be the same temperature and relative humidity. They want every room to be the same temperature. They want it so that I can wear my boxers all over the house all the time because I'm an American. Darn it, that's what I want. So 2012, air tightness, HVAC design calcs. Those are two big things that I know for a fact this builder might have forgotten to do or done wrong. So here's what the heating contractor came in and said, you know what, you should really get this thing tested first. First of all, he said that the equipment was likely too small and that the fan was working way too hard and just running 24 hours a day, and that is why the electric bill was high. He recommended the testing, which is really, really smart. However, he gave my client a bid to install 7 tons of air conditioning instead of the 4 that is already there. Thinking like, okay, so if this hypothesis is true that the equipment is too small, then this is what we're going to do. And going 50 kilobtu over on heating capacity. So here's the house. Now on the left, I want you to notice that we've got this chimney on the left side of the house as you see it there. Over on the right side, this is the front door on the right picture there, you can see, and there is a sensor there. And if you know what that sensor is, then raise your hand. And if you don't know what that sensor is, then I'll tell you. It is a sensor for an electric snow melt heater for that front stairway. Now take a look at that front stairway and think about my client. My client is not a 60-year-old man. My client is younger than I am. He's probably 32. He and his wife are both professionals. Perfectly healthy, no reason they couldn't shovel 7 stairs and a tiny stretch of sidewalk. So that's interesting. These kinds of houses that are built in wealthy, privileged neighborhoods, they think that everybody who's going to live in here is going to want these extras, these bells and whistles. The bells and whistles can get in your way. So anyway, that's something to take note of. Also, you can see right next to that there is another chimney. Now let's take a look at the plans here for a second. This is the second floor plan of this house. You can see the chimney at the top has a flue that's marked out over here on the left. And at the bottom, there's a second chimney, and that chimney has nothing going on in it necessarily. You can see that there's drywall that's going to be installed in there, but very interesting. So now we know, and by the way, when I asked my client, how many fireplaces do you have here? He says 1. 2 chimneys, 1 fireplace. That doesn't add up. So very interesting. Now we can already see that the builder thought that they were going to do some things that they didn't end up doing. And that's always an issue because the plans should be very well, carefully designed, right? So this is the second floor bedroom where that chimney is supposedly running up the outside wall. Now you can see clearly in the picture that I showed you with that sensor that the chimney is not square at the bottom. The chimney is a gentle sloping curve. So how in the heck and I'm watching my language today, by the way, I want you to be proud of me for that. How the heck is this square cutout matching up with the shape of the chimney that is running up the outside of this wall? The answer is, it doesn't. So the answer is, there's something going on inside of here because corners are always your enemy, and anytime drywall takes fancy turns means that something is being hidden from you. So this is immediately something that I'm very interested in. So be suspicious of extra corners in a major way. So we're going to find out later, and not in this webinar. Also, we get up on the roof. Now the roof, this homeowner, unfortunately, he's only lived here for a couple months, so he had to go out and buy a ladder to get me up onto the roof because I carry a 4-foot ladder with me everywhere, and that gets me into most attics. These air conditioning units, as you can see, are placed on not sound vibration dampers. Those are playroom pads for children. That is not professional equipment, and I'm even more worried now. So all of these things are kind of indicating, and you're just looking for symptoms at this point. I'm not giving any recommendations to the client, but I'm noticing that this house has symptoms of somebody not really doing the full-on professional job all the time, okay? And that's worrisome. So here is the skylight. And when you look down into a skylight from the roof, which is important to get up on, you can see how the skylight was put together. In this case, you can see the edge of the drywall and the edge of the framing that the skylight is built into. And you can see clearly that that is not an air-sealed opening. Now, we'll talk about air sealing for different reasons later, but air leakage is a major, major thing. And if you don't know my 4-3-2-1 breakdown, you need to go watch that video because it's very important for you to be able to simplify and condense all of your knowledge into very simple approaches so that when you see a red flag, you know it's a red flag. A lot of people will walk around and see things and they don't know what they mean. There's our fireplace chimney, and there's our extra chimney. Interesting. Let's go take a look. So as you walk up, you can see clearly that someone had pasted down probably a piece of plywood that has long since flown away. I'm a little worried about where that went. And when we look down into this thing, you can see that it's a trash heap. So this poor guy has had trash being rained and snowed on all winter long. It's disgusting. And this leads to the house, right? Because it's a chimney that's connected to the house. So regardless of whether it's just moisture seeping in through the brick or whatever, this is wrong. There is no way that this is allowed at any time. So now we're starting on our punch list of what this builder is going to have to come back and fix. Now, the enclosure is obviously my big deal, right? So the chimney thing is an enclosure issue. The second biggest deal that I want to look for is before I turn on the blower door at all, I want to look for insulation issues and anomalies specifically is what we're looking for, and also air leakage. Now, I do not look for air leakage until the blower door is running, but I can also find moisture problems. So insulation and moisture are very, very visible before the blower door runs. I can see from both of these pictures. Now, I told you at the beginning, this is an 82-degree day. That wall on the left is being shined on by the sun. The hottest temperature in that wall is 79 degrees, and the coolest temperature is 73 degrees. Is this wall insulated or not? And the answer to that is yes, it's insulated. In fact, heat always travels from hot to cold. So what you're seeing is that heat is coming in from outside, because it's 82 outside, 70 inside, coming in through the wall. It's coming in faster through the studs than through the cavities. Therefore, the cavities must be insulated. So this is actually good. I'm happy about this. The roof on the right, sun shining on the roof. Roof hotter than inside. That roof, if you remember from a couple pictures ago, was black, not reflective like it should have been actually. So is this black roof. It's definitely hotter than 100 degrees. The hottest temperature in this picture is 76 degrees. So regardless of how I do my calculus of heat is coming in faster through the cavities than through the studs, and sometimes that reverses itself because of something called thermal capacitance, which we are not going to get into today. Regardless, the hottest temperature of this, if anything was uninsulated, would be way hotter than 76. So my insulation is not a problem. That is a good sign for my builder. So 1 for the builder, Yahoo! So now I need to find out, okay, what else? Because our job is to inspect first, diagnose with testing second. That is a wine cellar air conditioner. Now, if you do not have clients yet who have wine cellars, I highly recommend it. They are very wealthy, and they tend to have the money and not the time. So they're willing to pay for something to get done right. So anyway, work for those people. But if you have one of these in your basement, think about what it does. It's moving heat. Any air conditioner or heat pump moves heat from one place to another. So it's taking heat out of the cellar, and it's dumping it into the rest of the basement. Maybe they don't like that. So maybe they did what this client did, and they dumped the AC to outside. So let's go ahead and just make an inventory of all the stuff that's going on HVAC-wise. This is a complicated house. We got 2 furnaces with an an AC connected to each. We have 1 power-vented water heater. That's better than atmospheric draft. I'm happy about that, but it's not sealed combustion. We have 1 wine cellar AC that is dumping hot air to outdoors. So where the hot air would come out of the unit inside the mechanical room, they've actually taken a duct and connected that to outside. We have 1 giant kitchen exhaust hood. Of course, if you haven't been in one of these houses, you would know that that would happen. And we've got 6 bath exhaust fans. We have 2 snow melt heaters and 1 steam shower, all of which are electric. And last but not least, we have a radiant floor boiler. Now, just looking at this list, do you think that there's not enough heating and cooling capacity in this house? Based on the fact that we know that the insulation is actually acting pretty good. Now, we need to obviously know by testing it. So let's just get into some of that stuff. So we're going to test what is obvious. That is always the first step. Don't go around testing something that's really obscure. If you're like, oh, I'm pretty sure it's this, test that. Go ahead and get out of the way. Don't do your worst case depressurization spillage test because it's like, nah, I don't really care about that right now. So enclosure air tightness is what I am looking at. Supposedly, in the plans that I have, miraculously, it says that the whole house was spray foamed. If that is true, then I will end up with a tight house if it was done right. So what we're expecting to see, I do not use the BAS. If you know what the building airflow standard is, try not to use it because it's not a real thing anymore. That's from 1989. It's over 30 years old. Don't use that. What I use is what everyone else will be using soon, which is your state code air tightness. And I happen to be broadcasting from Florida right now, but in Florida and in Chicago, it's the same. The state code requires 5 air changes per hour. And that, in this particular home, is 4,110 CFM50. What I actually test is 1,467.5. Now, why is the 0.5 in there? I'm not trying to be a schmuck. That is the average of two numbers. It's the depressurization and the pressurization. Pressurization is way higher than depressurization in this case because we have a lot of exhaust fans, and each of those has a backdraft damper that activates and blocks air when I'm in depressurization mode, and it blows wide open when I'm in pressurization mode. So obviously those are two different numbers. I take the average of the two because that is what is required by your state code. You need to read that thing. It cites the ANSI standard for it. So what this means ultimately is that we've got a really tight house. Now let's go ahead and just do the zonal pressure testing because that's important. We know that the interior wall cavities, the exterior wall cavities have hardly any connection outside. The basement mechanical room, which has quite a big number of connections outside, is only 9%. And the top floor, which is the top floor exposed to with exposed ceiling and exposed front and back walls and left and right walls, most exterior facing of any room in the house is only 5% connection when you close that room off. So that's all fascinating. What that says to me is that this enclosure is fantastic. That is a very well-tuned enclosure. The enclosure needs hardly any opportunity for improvement, right? So we don't need to waste any time trying to do air sealing or insulation on that thing. Now, let's talk about HVAC. So the kitchen exhaust, when you turn it on and all of the doors and windows outside are closed, you get -8 pascals. Now, if you have worked in these kinds of homes that are tight and have giant kitchen range hoods, that is not a surprising number. Here is a surprising number. When you turn the wine air conditioner on without the kitchen exhaust on, it also depressurizes the house by 8. In fact, when you turn all 6 bath fans and the wine AC, which dumps outside, and the kitchen exhaust on, you get -29 pascals. And I want to remind you that this house has a fireplace in it that is ducted with a chimney. And I don't mean ducted in a normal sense, but it's got a chimney attached to it. And that's not good. You're going to get smoke coming back into the house in all cases. So let's go ahead and start analyzing what's going on HVAC-wise with testing. We have our ideal airflows here in the middle column. Some of them say not applicable. That is because those are powder rooms. Fart fans is what most contractors will call these. I think that's a nasty word, so I don't use it. But ultimately, when it's in a powder room or a toilet room, it doesn't matter how much they pull because it's mostly just based on odor, right? So what you do need to worry about is the shower rooms and the bathrooms. So those all should be pushing 50, and that is state law because it's built into the IECC. And every single one of these exhaust fans is pulling way less than it should be pulling. Secondly, all of these is a nice Panasonic fan that has an adjustable flow and blah, blah, blah. It resists static pressure and all that stuff. And they should be super, super quiet because that's the way they're designed and built. But all of them are noisy. So I'm going to get to that in a little bit. Now, the HVAC system design. This is something that was the primary cause of what this person was thinking of when they called me. We've got two systems. We've got basement floor 1. That's a 2-ton air conditioner paired with a 75 kilobtu furnace. That's output, by the way. The target airflow for a 2-ton air conditioner, 400 CFM per ton, is 2 tons times 400 is 800 CFM. The maximum total external static pressure, which we're not going to get into how you measure, you can always read my book. And by the way, you can preview all of that book, all 218 pages at homeperformancebook.com. I'll give you that link at the end, is 0.5 inches of water column. Okay? Now, the second system is floor 1, floor 2. That also is a 2-ton air conditioner, but this one is paired with 56 kilobtus per hour, and that's output also. Target out airflow for this, also 800 CFM. So I want to just point out to you that we've got 2 ACs that are supposed to push exactly the same amount of air, but we've paired them with 2 different furnaces, meaning 2 different air handlers. That means that you have to switch around your taps inside the circuit board of that furnace, and based on the fact that we have playroom mats underneath the air conditioner on the roof, I'm betting this guy, there's no way he did that. So let's find out for sure. Tested performance, right? We're looking for 800 ideal. We had 1075 CFM on basement floor 1. That's the bigger furnace. That's 275 CFM over what we were looking for. Interesting. The total external static pressure for this one is super high, more than twice what we were looking for. We test the other one, and we've got almost on the dot what we were looking for CFM-wise. That looks like the right pairing. The total external static pressure here, also twice as much as it should be. So I just want to point out to you that I'm using a true flow plate when I measure these flows, not a pitot tube or an anemometer or hot wire anemometer or anything like that. And also that these systems have the exact same filter and return plenum. That is not allowed. If you have bigger airflow, you need a bigger filter, you need bigger everything, right? So because you don't want to restrict, that's a big, big problem. So let's look at the electric bill. Second reason that he called me out. The front and the rear electric snow melt heaters are installed, and there's 2 of them. Again, not just one, right? They each have a sensor. They each run 30 amps at 240 volts. That's 7.2 kilowatts. Now let's just think about this for a second. I'll skip all the math, but if you were to have both of these running 5 hours a day for 30 days, 1 month, that would equal the 2,000 kilowatt hours that he saw dropped from March to April. So we just found out that there's probably almost nothing to do with anything else in the house except for these stupid snow melt heaters that are the bane of my existence. So tiny little bit of sidewalk on the front of the house, tiny little bit of sidewalk that's underneath a whole bunch of stairs on the back of the house. Totally useless. So we'll get into the recommendations in a minute, but in the meantime, that's what I'm thinking, right? So the analysis of all the testing that we've done is that the major problems are absolutely not the enclosure's fault. The builder actually did a pretty good job with the framing, the insulation, and the air sealing, right? The HVAC for sure is overcomplicated. We've got way too many pieces of equipment in here, and that means that there is no way for anybody to think very clearly about this unless they do a bunch of testing, which clearly did not happen since I found a bunch of stuff that's wrong. The exhaust depressurization is an issue because the fireplace is going to backdraft. If they were to build a fire, most likely smoke and carbon monoxide would come back out of the chimney, because if you've got -8 plus -8 for the wine air conditioner and the kitchen exhaust being on, then there's no way that this thing can fight that. And the water heater is probably going to malfunction because that thing is only rated up to -15 pascals before it might start having problems, and that's according to BPI standards. The exhaust fan underperformance is also a problem. Now this is going to have multiple effects. So the installer probably forgot to remove the tape on the backdraft damper. Now here's what happens when you ask somebody, did you maybe take the tape off of that backdraft damper before you installed it? And the guy says, of course I did. What do you think I am, an idiot? I want everyone who's listening to my voice right now to raise your right hand and repeat after me. Sometimes, my audience in the room with me, say this with me. Sometimes I am an idiot. Good. I have an audience here in Florida. This live audience is great. So I hope that you all said that because yes, I am an idiot. And I double check myself. You double check yourself. Everyone has to double check themselves. That is what the testing is about. So you check the tape, and yes, the tape is still on there. There's no way that it's not. So that's super easy. Now, is the HVAC too small? We do a manual J calculation because guess what? Required by law. One of the things. So we've got 2 systems, basement floor 1 and floor 2, floor 3. So we're going to do a block load calculation on this, okay? And this is something that I included as part of my analysis on this house. You can see clearly that my square footage of room area is not 4,800, it's 2,400. Why is that? It's because I built 2 blocks, 1 for each system. So I don't actually have to pay attention to the actual square footage of the floor area if I just build the entire enclosure as one big room. So you'll see that that is a thing that'll come up when you build this as a block. So square footage, 2,400, but what I can see clearly here is that the heating required is 93,778. Let's just call it 94 kilobTUs per hour. The cooling required is 40 or 41 kilobTUs per hour. That's 3.5 tons, okay? Now what we have installed here is 173 kilobTUs per hour for heat and 54 for cooling. Is the HVAC too small? The answer absolutely is no. Hi, my name is Corbett. I used to play piano for ballerinas 7 years ago. Why am I allowed to tell HVAC professionals who are the ones who know about this stuff how this works? And it's because I am one of the few people that is actually double checking this stuff. There are HVAC professionals out there who are doing this work and who know how to test and how to design, and you need to be working with those people every single time. Are they more expensive? Yes. Do you want it done right, or do you want it done the wrong way? You want it done right, period. So you pay more, you get somebody who knows what they're doing. And this never happens. You don't want somebody who came from playing music for a living to tell you like, oh, this is actually how you do your job. That's embarrassing. I don't want to live in that world. You don't want to live in that world. Let's not live there. Now, the radiant slab, let's talk about this for a second. What the radiant guy says is, I'm going to install insulation for you. It's going to be this little thin Mylar blanket that's got this little bubble wrap in it. Guess what that's worth insulation-wise? He's going to say, oh, it's our whatever. Whatever he says, it's not worth that. It's a piece of plastic that's got radiant on it, okay? A radiant barrier, excuse me. So the big thing to remember is that heat travels from hot to cold So wherever it is hottest and coldest, and by the way, the coldest thing that this thing would like to heat is the ground. The ground is 55 degrees. So there's no way that his little blanket of whatever that's not even specced in the detail here that you can see is going to protect that. So therefore, we are not going to use the radiant, right? And that's going to be in my list of recommendations in a second here. So there's no insulation. There should be no radiant heat in this slab. That's totally ridiculous because it's wildly inefficient. Okay, so here's what all of the testing and everything that we analyzed means. The heating and cooling load calculations were not done, or they were done and they were not followed. That was our Manual J. Manual D is also required, and that is the duct design calculations. I know for a fact, based on the static pressure and the airflows, that it was not done, or it was not done properly and followed, because the ducts are too restrictive. The Manual S is also required by law, and by the way, this is going to be the case in most states by 2017. The size selection of the equipment was not followed, because I know for a fact that not only is this equipment not too small, it's way too big. So it was not followed there either. Therefore, we can go ahead and assert to this builder, you didn't do any of this stuff, and now the burden of proof is on the builder. The poor builder, like I work with builders and they're my friends and everything, but like this guy clearly did not do these things, and if he did, he has to then supply those documents, and we will double check them, and most likely they're not right, because there's no way, if the proof is in the pudding is spoiled. There's no way. So here's my recommendations for the builder. Number one, you have to increase the bath fan airflows, because all of them should be pushing 50. We have to fix the chimney problem, because there shouldn't be rain and dead birds and trash falling down into my chimney and then making my front room cold. We have to fix the duct design problems. That means upsizing the ducts or downsizing the equipment or whatever you want to do. I don't care, as long as you fix the fact that we've got airflow problems, static pressure, and the rooms are different temperatures at different times of day. Lastly, we have to make sure, and these are all musts, reduce the AC roof noise with actual vibration pads, which they sell at actual air conditioning stores, not kids' toys. The Skylight shaft tops have to be air sealed. Why do they have to be air sealed? I already said that the air tightness of this house is fantastic. It is because we are worried about condensation, not energy efficiency. This is the problem with your utility rebate programs and your weatherization programs. They're not going to pay you to air seal that Skylight shaft, even though it has nothing to do with energy efficiency. It's all about the fact that we might get lots of water condensing in the roof cavity when that warm air gets around that gap, and then we get mold and we get air quality problems. But their job is to reduce your energy consumption. That is why I follow the auditors who do rebate programs and weatherization work. And I get hired for my rate, which is a lot higher, I'll tell you that, than the weatherization or the program auditors. And they get two, because the first person didn't actually deal with all this stuff. You can be the person that actually deals with the problem. The wine air conditioner also needs to be dumped into the basement great room, not to outside, because that is depressurizing the house way too much. Now, I've got recommendations for my owner as well. First of all, we're going to turn off those snow melt gauges, because that is stupid and it's way too many bells and whistles, and we've got young people who should be using their muscles and shoveling snow. It'll be great. Good exercise, no snow to worry about, and this was way wasteful. Also, we're going to go ahead and deactivate the wine cellar AC. Even though we just ducted it back into the house, we're going to turn it off, because this client, and I only know this because I asked, do you love your wine cellar? And he said, well, as you can see, we have a few bottles of wine in there, and we only bought those bottles of wine because it looked stupid to have a big empty wine cellar down there. So he doesn't like the wine cellar either. Let's just take those wine racks out of there, turn it into storage or whatever. We're going to avoid using the radiant slab at all times, because we've got more than enough forced air. We're going to only run the kitchen exhaust on low speed ever, because that is a safety problem for the power vented water heater. Now, if you want to become a black belt at all this stuff and know how to use these performance tests to be a ninja, then you need to come study with me for 6 weeks for the fall fast track. That starts every Labor Day of every year. And it's you and me and a bunch of people from around the country and hopefully around the world. We had somebody from Canada last year. I'm aiming for Southeast Asia and Africa this year. Aiming high, right? So that can be found at homeperformance.training. You can pre-register for free, and you just get some bonuses and you get a place in line, because it's only limited to 100 people. So lastly, you can find a bunch more stuff at my website, which is buildingperformanceworkshop.com. Thank you very much for coming, and I will take questions now.